Probability is one of the most important mathematical concept that we use in our day-to-day life. So, what is probability? Probability means the chances of the occurrence of an event. So, before I set out basic concepts of the probability, let us come through some basic examples of the probability that we use in our day-to-day life. First example, suppose there is a question in your notebook and there are chances that the question can appear in your exam. So what action you will take in this case? Of course, you will practice that question again and again, and even you will also revise that question just before appearing on the exam day. Let's take one more example. Suppose you need to purchase a bulb and you have two options to purchase a bulb, and in first bulb there is no warranty, while in other bulb there is a warranty of 1 year. So there are chances that the first bulb can fuse in its first hour of operation. So I think you will not go for that bulb, and you will purchase a bulb with a warranty. Let's take one more example. Suppose there are chances that it can rain today. So what action you will take? Whenever you will go outside, you will keep an umbrella or raincoat with you to protect yourself from the rain. So these basic definition, these basic uh, estimations helps us to make a course of action in our day-to-day life. So the application of the probability to personal life helps in improving their decision making, right? So let's come to some basic terms of the probability. First is random experiment. So what is random experiment? An experiment whose all the outcomes has to be among a set of events that are completely known, but exact outcome is not known. For example, if we throw a dice, we all know that all the possible outcomes will be 1, 2, 3, 4, 5, and 6. But what exactly will come, we don't know. Hence, throwing a dice is an example of random experiment. Similarly, if we toss a coin, there are two possibilities, yeah, right? Whether it will come head or it will come tail. So we know that these two possible answers can come when we toss a coin, but what exactly will come, we don't know. So such kind of experiments are known as random experiment. Let's come to the next point, which is sample space. So a set representing all possible outcomes is known as sample space. So when we throw a dice, so the all possible outcomes are 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. These are all possible outcomes. So this is the sample space for a dice when we throw that dice. And similarly for a coin, the sample space will be, if we toss a coin, the sample space will be head or tail. Let's come to the event. So set representing desired outcomes of random experiment is known as event. So when we throw a dice, suppose the desired outcomes are number to be even. It means, desired outcomes are number to be even. It means it will be 2, 4, and 6. If numbers are coming 2, 4, and 6 on dice, it is the event, right? So event will be number to be an even number. Let's come to the next definition, which is non-event. So outcomes that is opposite to desired outcome is known as non-events. So here in previous case, the event was number to be an odd even number. Now what is non-event? Non-event is if a number appeared on the dice is a odd number. So that is an non-event. So examples of non-event will be here. Examples of non-event will be 1, 3, and 5. So all the odd numbers will be examples of non-event, because event was defined as all the even numbers. Let's come to next point, which is impossible event. So let's suppose if I ask you what is the probability to get a 7 on a dice when we throw the dice with 6 faces. Of course, we don't have 7 on the dice, so there is no chance to get 7 on that dice. So the possibility, so there is no possibility now. There is it is impossible to get 7 on the dice. So this kind of event is known as impossible event, and probability of such event is always 0. So probability of impossible event, if it is asked, so you will tell that probability of impossible event is 0. Next topic is mutual exclusive event. So when occurrence of any of one event means another event cannot occur. Such examples are such experiments, such events are considered in are kind of mutual exclusive event. Suppose we throw we toss the coin. We toss the coin. So in this case, uh, if it appears head on the top face, so there is no chance that tail will appear. So such kind of experiments are known as mutual exclusive event. Next heading is equally likely events. So if two events have same probability of occurrence, that kind of events are known as equally likely events. So when we throw a dice, so the possible outcomes are, we all know that they are 1, 2, 3, 4, 5, 6. So any number can appear when we throw a dice. So the probability for all the events will be same. If we talk about 1, probability of 1 will be equal to probability of 2. Like matlab means that the appeared number is 2. So both have same probability. Similarly, probability of number to appear on dice is 3, is also equal to 4, is also equal to 5, is also equal to 6. It means any number can appear on the dice. So all the numbers have same probability, and that will be 1 by 6. We will discuss in next topics. Next is exhaustive set of events. So a set of event that includes all the possibilities of the sample space is called exhaustive set of events. Suppose event is that number is less than 3 and greater than 3 and equal to 3. So in this case, if event is less than 3 means 1 and 2 will come. If event is greater than 3 means 4, 5, 6 will come, and if it is equal to 3 means 3 will also come. So we will find that when we throw a dice, all the possible outcomes are your event, all the possible outcomes are your desired event. So such event is known as exhaustive set of event. Independent event, if occurrence of one event has no effect on the occurrence of another event, that event is known as independent event. Let's take an example of independent event. Suppose couple has first child as a boy, then it will not put effect on another child to be a boy. So such kind of events are known as independent events. And next is conditional probability. So the probability of occurrence of an event A given that B has already occurred, such kind of probability are known as conditional probability, and we represent these kind of probabilities like P of A over B. So let's take an example of this conditional probability. Suppose your event is that when we throw two dices and the sum will be 7, but condition is that on first dice we got 5. So such kind of cases are known as conditional probability. Now we have two kinds of formula to solve probability. First is empirical probability, second is theoretical probability. So in empirical probability, we have formula which is based on number of trials, and we also called empirical probability as experimental probability, and the formula to find empirical probability is number of trials in which event happened upon total number of trials. while in theoretical property this is also known as classical property, and the formula to find theoretical probability is number of favorable cases upon total number of possible outcomes. So we will learn these two formulas in detail. Let's take one example based on empirical probability or experimental probability. Here this is the question. In this question it is written that a coin is tossed 100 times. So here number of trials are 100 and head is obtained 59 times. So it is given that how many times we got head on the in on the coin. So on tossing a coin at random, find the probability of getting head and probability of getting a tail. So tell me, if 59 times we are getting head, it means 41 times we will get tail. Okay, first of all we need to find what is the probability of head. So to find probability of head, we have formula number of times event E happened. Here probability of head, we need to find that how many times head appeared on the face of the dice. So it appeared 59 times. So probability of head is 59 upon total number of trials. Here total number of trials are 100, so 59 upon 100 is the probability of head. 59 is a prime number, we cannot solve it further, so probability to get head is 59 upon 100. Similarly in next part we need to find what is the probability to get a tail. So number of times tail appeared on the coin is 41 upon total number of cases are 100, so 41 upon 100 is the probability to get a tail on the coil. Next, let's take example of theoretical probability. So question is, find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. So first of all, if we talk about sample space of this question, we are uh, tossing a coin. So sample space is either head will come or tail will come. So there are two possible cases. Now we need to find that what is the probability to get a head. So probability to get a head. So we need head. So there is only one case to get head upon total number of cases. Total number of possible outcomes are 2. Either it can be head or it can be tail. So probability to get head is 1 upon 2. Similarly, to find probability of tail, there is only one case in which we can find tail, and there are total 2 cases. So probability of tail will be 1 upon 2 and probability of head will be 1 upon 2. Next, one more example we will take for theoretical probability. A die is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, and an odd number. So first of all we will find that what is the probability to get a prime number. Okay, a die is thrown, so first of all we will find the sample space. So here sample space is all the numbers from 1 to 6. So 1 2 3 4 5 and 6, these are the sample space. Now we need to find that what is the probability to get a prime number. So in first case the event will be to get a prime number, and if we talk about prime numbers are 2, 3 and 5. So what is the probability of a prime number? The formula is number of favorable cases. So number of favorable cases are 3 upon total number of cases, these are 6. You can cut 3 and 6 by 3. So answer will come 1 upon 2. Let's take another example, second part of this question. It is a number lying between 2 and 6. So in this case event will be favorable event is number will appear 3. If number is appeared 3, it is our favorable case. If number appeared is 4, it is our favorable case. If number appeared is 5, it is our favorable case. So again there are 3 cases which are favorable cases. So the probability of a number between 2 and 6 is going to be number of favorable cases. There are number of favorable cases are 3 upon total cases, that is 6. So 3 upon 6, when we will solve this we will get 1 by 2. Another one, Third one, the favorable event is an odd number, so number will be odd. So if we talk about favorable cases of number to be an odd are 1, 3 and 5. So total there are 3 cases. So the probability of odd number will be, number of favorable cases are 3 upon total cases are 6. You can solve this 3 upon 6, you will get 1 upon 2. So the probability of an odd number is 1 upon 2. Let's take uh, let's come to another concept. It is use of conjunction and. So whenever we use and as a natural conjunction joining two separate parts of the event definition, we replace the and by multiplication sign. We will understand this concept with the one question. So question is, if we have the probability of A hitting a target as 1 upon 2, so here probability of A is given, hitting the target is 1 upon 2, and that of B hitting the target is 1 upon 2. So again probability of hitting the target is also 1 upon 2. Then the probability that both hit the target if one shot is taken by both of them. So here what is the event definition? Event definition is A hits the target and B hits the target. So it means here conjunction is and the concept says that if two parts of event are joined by and, replace the sign we will replace this word and by sign of multiplication. So here we need to find probability of A and probability of B. So we will replace and with sign of multiplication. So here we can write P of A into P of B. P of A is 1 upon 2 and into P of B is also 1 upon 2. If we solve it, it will come 1 upon 2 into 1 upon 2. It will give us 1 upon 4. So probability of A into probability of P is 1 upon 4. Next topic is use of conjunction or. So whenever we use or as a natural conjunction joining two separate parts of the event definition, we replace the or by sign of addition. So if we have, let's take a question. If we have probability of A winning the race as 1 upon 3. So probability of A to win the race is 1 upon 3 and that of B winning the race is 1 upon 2. So probability that B will win the race is 1 upon 2. Then probability that either A or B wins the race. So here conjunction is or and the concept says that we will replace this or by sign of addition. Let's write the definition, event definition. Event definition is A wins or B wins the race. So what we are going to do, we need to find P of A or P of B, and what I will do, I will replace this or by symbol of addition. So I need to find P of A plus P of B. Now P of A is 1 upon 3 and P of B is 1 upon 2. So we can simply solve this 1 upon 3 plus 1 upon 2 by taking LCM of 3 and 2. It is 6. Now 6 upon 3 is 2. 2 into 1 is 2. Plus 6 upon 2 is 3. 3 into 1 is 3. So 2 plus 3 upon 6 will give you 5 upon 6. So this is how we can solve questions based on probability, and these were the basic concepts of the probability that I have discussed in this video. Thank you.